Welcome back to the API World 2021 main stage. Up next, we have Kyle Fuller, Director, Developer, and Consumer at Foursquare. Kyle, if you'd like to join us here on the main stage,
Hey
welcome.
everyone.
Go ahead and take it away.
All right. Got a lot to go through here. I'll just jump right in. As you said, my name is Kyle Fowler. I'm our Director of Engineering for Developer and Consumer Products at Foursquare. And for those who may not be familiar with Foursquare, Foursquare is a leading independent location technology company. Our goal is to power experience and understanding of the world around us, power customers' location needs across many verticals, both around places of interest and as well as how people move. And kind of where we start into this talk is through how we've kind of been on a journey to build out our API products. Foursquare's API originally launched in 2011 as an extension of our consumer apps. We wanted developers to be able to use the same technology that we were using to build our apps to build brand new experiences. So that product's been around for a really long time. And as we've kind of grown the company, grown our business, we had a lot of success with that API. But as things kind of went on, we realized that in order to allow the API to really flourish as a product and not just as a companion to our consumer apps, we need to rethink it, to detach it from how it was connected with those products and to better support our developer customers in the long term. So kind of how we got here today using Foursquare API as a foundation, and how we rebuilt our new API with the goal of kind of creating a refreshed and developer-friendly service that kind of meet the needs of our customers, both small independent developers and large multinational corporations with great location-aware apps. So the first thing we'll kind of jump into is how we went about this. We kind of focused on four main areas here. We wanted to establish and identify what an SLA looks like for our customers. We wanted to enhance the developer experience, strengthen the data quality that was coming back in our API responses, and overall, improve performance. Right now we're able to offer a SLA of 99.9% uptime and availability. We spent a lot of time working on our developer experience. We can slowly introduce data changes to our APIs to improve quality and usability of our products for our customers. And then how do we use new infrastructure, new technology to expand to cover our global customer needs and scale our business to meet their needs. So that's kind of the areas we'll get into here. So kind of taking a step back, from Foursquare's perspective, what do we think it takes to build an enterprise-grade API? We see a lot of challenges facing engineering teams when building an API, and the main ones that we like to focus on are usability, reliability, availability. How do you make continual improvements, ensure consistency, and monitor the product? From usability, you really want your customers to enjoy using your API. If they don't feel like it's easy to use, if they feel like they're bashing their head against the wall every time they try and update their API calls or integrate a new one, you're going to lose customers. And so we really wanted to have a customer-focused approach to start off with, make sure that everything we did revolved around how easy it would be for our customers to use our API. And after usability comes reliability. If it's easy to integrate with, but everybody that uses your product has problems with its reliability, its response times, its consistency, you're going to lose those customers no matter how easy it is. And then, as you get more and more customers, you're going to expand your product functionality and features. So how do you design your API products in a way that lets you make changes continually without impacting your customers, without having to send out monthly emails that say, hey, we're releasing this new feature. It's going to break this thing that you have integrated with already. We really wanted to make it easy for our products to improve over time. And then just an internally consistent behavior between our products. How do you make sure that every API product that you put out kind of has themes tied together with the other ones you release, and make sure that um, they don't use one API product from your company and then come and use a different one, and it just behaves completely different. You lose a lot of the shared knowledge and understanding that can be beneficial to your customers and how they consume your products. And then finally, making sure that you have visibility into how your customers are using your products, how your products are behaving for your customers in the same way you would any other product feature. So let's talk a little bit, our take on how we think you get that right. For me and Foursquare, kind of the biggest thing was to plan before we write any code. We, in the development of our new API product, we've spent 2 months planning the API technically before we wrote any code. And we wanted to make sure that no matter what the business logic was, things like what do we want our API path structure to look like? Used this analogy earlier today in a fireside talk, but the API is just like any product with a UI component. It needs a well laid out set of design principles. It needs testing. It needs feature completeness before you even get to implementing it. And APIs are the same way. Path structure, authentication style, response style guides. How do you bill your customers if you have a paid API product, and do your design decisions have impact on how much it costs your users to use it? Thinking very carefully about how you put those make those decisions has a big impact on the success of your product. Because kind of once an API is out, it's a lot harder to change because your customers have spent their hard engineering hours integrating with it. So set the boundaries within which you want to be endpoints. So you don't try and solve all the problems at once. Leave yourself room for not adding all your features on day one, and that will kind of help you take an iterative approach and design your APIs in a way that allows you to make continual improvements. And then, secondly, or I guess third, what kind of user experience do you want to enable with your products? You should know your potential customer use cases, how they're likely to use it in what types of applications. That will also impact the structural decisions you make before any business logic comes into play. The content of the response really only matters as much as it fits into the customer's products. And carry on with that, the developer ergonomics. Like I said, once you launch it, it's kind of hard to change. People don't want to be updating their integration with your API every few months. They want it to be consistent and comfortable to use. So for us, the things that we did, we predetermined what our data schemas looked like, our rules for rendering every field, that we would use snake case in our parameters and our response fields, header-based authentication, and path-based versioning. And I think, one of the big decisions that we had to make, was, do we stick with like a REST-based architecture for our API, or do we move on to something newer like GraphQL? We knew we wanted to allow our customers to get a flexible response to select the fields that they wanted to receive, because that in turn impact how much they were billed for our calls. We have some data that is at a higher price point than others. Naturally, GraphQL could have been a great fit for that, but we kind of felt as a team that the developer tooling around GraphQL was still a little not quite mainstream enough to put the main Foursquare API product into this environment. I think you see companies like GitHub have 2 versions of their API, one GraphQL, one REST-based. And I think that was a big decision for us at the beginning, and one that would have been really hard to change after the fact. Then something that may, obviously you want documentation at the end. But I would encourage you to don't forget documentation at the beginning. You want to make sure that you have your customer at the front of mind right from the beginning. How do you document your endpoints? How do you keep them up to date? Do you have to manually update the documentation anytime you publish changes, or is your documentation annotating your code and generating an open API file or something like that? You can't really throw it together at the last minute. Sometimes when you're going to write the documentation, you'll figure out, oh, this does not make sense at all. We're trying to write this out to make sense to developers. It doesn't even make sense to us when we're writing it out, and you have to go back and redo work. So make sure that you think about documentation beforehand. And then, what I consider a second stage of documentation is onboarding. You're going to have a developer console of some sort, likely, where your users get their API keys, making sure that they know how to get from your documentation to your console to generating API keys to then using your service is really important, and can't underestimate the value that offers to your users in their long-term happiness with your platform. So make sure they can understand their usage, how their implementation is impacting their cost through stats and data in your console. And so that's kind of like the pre-work. And obviously you're going to go write your code, write your business logic. And it's kind of the next part here. I want to dig in a little bit on the, after you've written your code and you're ready to, get it out into the customer's hands, things like SLA best practices come into play. Part of the pre-work is really determining and understanding what kind of applications your customers will be building with your APIs. Are they 9 to 5 apps for business users in a specific country? Are they consumer products used around the world 24 hours a day? That will really change kind of how you think about your SLAs, whether or not you can have scheduled maintenance on your API products. You might be in an industry where it's okay for a 30% error rate in your APIs at 3 a.m., but not at 10 a.m. So that will have kind of a major impact on how you staff your teams, how you staff support structures and sales teams, and basically a lot of your company can be based around your SLAs. For us, we have customers who are building apps for end users all over the world. They expect highly available response times and availability from our APIs. Their end users expect to use our customer's product with no issues. So we have a 99.9% SLA and around-the-clock support teams on call to handle any production issues. And that's an artifact of our customer base. We would probably make different decisions if those weren't our customers. So I think it's really important to consider how your SLA will impact the work expected of your engineering and product and support teams. So now, after you've written code, you also need to think about the metrics. We talked I talked a few minutes ago about monitoring, but beyond SLAs, how do you measure and share the performance of your products? You don't really want to be secretive. Your customers are users. They see errors. They see latency spikes on their systems. You should have a way to expose those to your customers, whether it's through a status page or graphs in your developer console. Their experience should be reflected in your presentation of their experience, if it were, because you don't want to be in the state where your site says you're green and all of your customers say, no, I can't hit your site. That drives a lasting impression kind of your API products. Then, one of the other things is how you handle and communicate recovery during outages. is there a way for customers who are being impacted to get in contact with you or be told very clearly what's going on? And we've had a lot of occasions where even if the community, the outcome is poor and things are not working very well, as long as you're consistently in communication, your customers at least feel like they are uh, have the same level of information as you do and don't feel like they're being kept in the dark. Um, so just one thing may also to consider is some customers may have different um, issues than other customers. So consider building customer level observability. Not all customers are the same, and being able to investigate on an individual customer basis is a way that you can speak directly to their issue. And then continuing on about performance, you know there's always the perceived latency of your API products, and then what you think it is on your server side. Um, so I was encouraged. Don't forget to load test. Things can look fine at 100 QPS, but what does it look like if you are up at 10,000 QPS? Obviously, every application is different, but kind of stress it to where you think would be really successful for your API product, and then take it another 20% further. And then make sure. So we have a system internally we call our dark test system, where we are able to replay traffic from our other API endpoints to new ones that we are trying to roll out. So we try and match expected use case throughout a 3-day period. We'll turn on a dark test, add some multipliers to the traffic, and as the day ebbs and flows with the API volume, and ours isn't all flat, it kind of comes and goes as the day goes on. We can match expected customer behavior. We can stress test it. We can multiply it higher without impacting our customers. So that's before we launch. So make sure that you can kind of set those standards internally before you launch. And then observability on your internal side for your API performance is important. One that we've learned kind of the hard way over the years. That obviously the customer is always right, just as in any business. But we had a customer in South Korea, for example. They would notice 3-minute blips in connectivity, very random times, maybe like once a month, twice a month at most. But it never triggered any alarms on our side. We never really even noticed it. We never saw those blips, but they did, and they were the only customer that saw it. We had to go spend a lot of time figuring out that one of the application load balancers would fill up with connections, clear all of them, and take 2 minutes to build them back up to our backends. But we didn't have observability on that particular piece of our stack that would have alerted us. So, every layer of your infrastructure is important. Make sure that you see or you can have the same experience your customers have. Build in the alerts to support it. And then I think we're running up to question time here. You're kind of a last smattering of thoughts here. Always track your costs. They can run away pretty quickly if you're going to deploy in multiple regions around the world. Your costs often duplicate with every region. So make sure that kind of ahead of time how to plan for those costs. On the performance line, again, your customers are going to audit the performance in ways that you don't imagine. They're going to abuse your product in ways that you did not imagine or plan for. So know that those will always come up. Make sure you think about security of your infrastructure at the beginning. And planning, don't leave security to the end, especially if you're dealing with user data or PII. That will only come back to bite you. Make sure that you think about that at the beginning. I suppose that's maybe obvious to say, but felt like important to say here. And then, depending on who your customer is, don't forget your legal team. Your legal team will write terms of service. They will write usage guidelines, acceptable use policies, caching policies. They will be writing all these policies to protect your company. So, as a product manager or engineer, be an advocate for your customer. Make sure the terms are friendly to them, and make sure that you build with the customer in mind always. You don't want the legal teams, your potential customers, to read through the agreements and think, I could never sign this. You want it. That's a very important thing. So that is kind of the end of this here. We had a few minutes for questions. I don't know if we had any, but I have a few to take here. If have 5 minutes left or so, if we have any questions. I guess one thing I kind of forgot to mention in the continual improvements section was how you get feedback, and how you continue to make your product better. Um, for us, we have kind of three points of contact. Our sales engineering team, pre-sales, our customer success engineering team, post-sales, and then feedback buttons in our developer console and API documentation. All ways for our product and engineering team to listen to the customer, make changes to make their lives better. Looks okay. We do have one question. So looking to set up a KPI for each API service and trace them, utilization, latency. Yeah, for KPIs, indicators, a lot of it kind of depends a little bit on your architecture. So for us, like one of the important things is thread pools. So we run in a JVM Scala-based stack. Thread pool utilization, not just system CPU and RAM utilization, is often a very strong indicator of our potential performance issues. So that's one that we look at. And then things like network transit, breaking down latency into network transit, DNS resolution, server-side latency. Anytime you're using a remote database, like a Mongo or DynamoDB, make sure that you have monitoring on all of those pieces, because one thing falling over can have a cascading effect there. Hopefully that was kind of what the question was looking to get answered. So improving latency when data is large. So there's probably a few ways that we've tackled that. We have a lot of incremental roll-ups of data served in large key value store formats. So we are very rarely in our search endpoint latency on the server side right now is around 40 milliseconds. And so to enable that, we pre-compute a ton of rollups and slices of our data. And this does depend on kind of your use case. But we have a lot of extra storage and serving infrastructure for our data that powers low latency queries, because we know ahead of time kind of how the queries will be made, and we can optimize. So we're paying extra on the storage cost for storing large binary files. We use a system called HFile. It's just a large key value store. So we pay a little bit extra in infrastructure costs for serving those, but we get that from increased reliability and lower latency. Those queries return in a millisecond. And so knowing if you can pre-compute a lot of things is a big potential win for latency. And then putting things like memcached or in-app caching ahead of in front of your queries, depending on how often they change, can also be a big benefit there. All right. I think that is all of our time. I appreciate everybody tuning in. It's good to be able to share with you all. Hopefully everyone has a great day. And thank you very much.
Thank you, Kyle. We'll be back on the main stage for our next talk in 5 minutes.